Hi students, today we are going to see some circles, right? So already we know some properties. By using the property, we are going to find, right? We are going to find the values. I already told you that we are having a right angle triangle. So with the help of Pythagoras theorem, right? We will get a right angle. We are having a right angle triangle with the help of Pythagoras theorem, right? Right angle triangle means usually which property we will use it? Pythagoras theorem. By using the Pythagoras theorem, we are going to find sides, right? So we are having three sides, right? We are having three sides in a right angle triangle. One is nothing but what is that? Adjacent, opposite, and hypotenuse, right? But here in this chapter, right, we are having three things. One is nothing but radius, another one is nothing but length of the tangent, another one is nothing but distance from the center point to the center point and the external point. Distance between center point and the external point, right? These three things alone, right? But with the help of right angle triangle we will find it, right? Okay, first we will read the question, right, and sort out the given, and based on that first we will draw the diagram, and what they ask you to find we will find it, right? Okay, so number one, find the length of a tangent to a circle. So what we want to find? Length of a tangent. We want to find the length of the tangent to the circle from an external point at a distance of, wait, from an external point at a distance of 5.0 centimeter from center of the circle of radius 3.0 centimeter. So first we will draw the circle, right? Have drawn a circle with the center point O, right? What they are saying, what we want to find, we want to find the length of the tangent. So first I am just marking an external point, right? I am just marking an external point. They didn't give the name of the external point, you just give it, right? I'm just taking as A, right? I'm just taking the point as A, right? Now I'm going to draw the tangent, right? So how we will draw the tangent? First we want to draw the, yes, we want to mark the point, right? I'm just marking the point on a circle and giving that name of the point is nothing but P, and joining these 2 points, right? And just joining these 2 points by using the scale you can join it, right? Wait. So in this diagram, A is nothing but external point and P is nothing but point of contact, right? And AP is nothing but tangent, right? AP is nothing but tangent, and OA is nothing but radius, right? OA is nothing but radius. And what is AO? AO is nothing but distance between the external point to the center of the circle, right? The external point to the center of the circle. So distance between the center point and the external point. Distance between the center point of the circle and the external point of a external point, right? Okay, these three things. So already we know that by using the property, right? Already we know the theorem, right? What is that? The radius. Radius will be perpendicular to the tangent, right? So angle P is nothing but right angle, right? Angle P is nothing but right angle, right? Now what we want to find? See, so first you want to know that. So which is adjacent side, opposite side, and the hypotenuse. See, and this is the right angle triangle, right angle, and this is nothing but base, and this is altitude, right? This is base, altitude, and this is nothing but hypotenuse. OA is nothing but hypotenuse, right? First write the given. What are the given? What are the givens we are having? So see that, find the length of the tangent. To find what we want to find is nothing but length of the tangent, right? Length of the tangent. Length of a tangent, that is what we want to find. Length of a tangent, that is AP, right? AP is nothing but length of a tangent, right? OA is nothing but distance between the center point and the external point. OP is nothing but radius. Okay, see the length of the tangent only we want to find to the circle from an external point at a distance of 5.00 centimeter from the center. So at the distance of, so there is nothing but external point and the center point distance is nothing but 5.0 centimeter, right? That means OA is equal, right? Given OA is equal to 5.0 centimeter, right? From center of the circle of radius 3.0 centimeter. Radius is nothing but OP, that is 3.0 centimeter. 3.0 centimeter, right? So OA is equal to 5 centimeter or 5.0 centimeter, and OP is something but 3.0 centimeter. Now we want to find the AP alone. I am just taking as X, or we can keep it as AP itself, no problem, right? So we know it, what is it? Triangle OPA is something but right angle triangle, right angle that P, right? Triangle OPA is nothing but right angle triangle, right? So with the help of Pythagoras theorem, right? By using the Pythagoras theorem, I am just going to find the length of the tangent, right? Length of the tangent, that is nothing but AP, right? See here, OPA is a right angle triangle, right? OPA is a right angle triangle. So by using Pythagoras theorem, right? OA square, that is hypotenuse square is equal to adjacent square plus opposite square. So which is hypotenuse opposite to the right angle, right? For the opposite to the right angle, which side is the opposite for the right angle? OA is nothing but opposite side for the right angle triangle, right? So right angle. Right angle. So OA is nothing but hypotenuse. So OA square is equal to OP square plus PA square. Now we know the value of OA and OP. Substitute and simplify, we'll get the value of PA. So what is the value of OA? OA is something but 5 centimeter, right? So 5.0 centimeter. I'm just taking as 5 itself, right? So 5 centimeter, right? 5 whole square is equal to OP. We know the value of OP. OP is something but 3. 3 square plus PA square. So 5 square is nothing but 25 is equal to 3 square is equal to 9 plus PA square, right? Bringing this 9 to the LHS, plus 9 will become minus 9. So 25 minus 9 is equal to PA square is equal to how much? 16. 16 is equal to PA square. But what we are needed? The length of PA alone we are needed. Here we are having square. So taking square root on both sides. So it is nothing but square root of PA square is equal to square root of 16, right? Square root will get cancelled. So PA is equal to square root of 16 is nothing but 4. So 4 centimeter. Therefore, the length of the tangent, right? Therefore, the length of the tangent of a is nothing but, right? Length of the tangent to a circle is nothing but 4 centimeter. Therefore, the length of the tangent to a circle is 4 centimeter, right? This is not 1 marks, 2 marks, right? Based on, they will ask you in 1 marks or 2 marks, right? So number 2, a tangent PQ at a point, P of a circle of radius 5 centimeter meets a line through the center O at a point Q, so that OQ is equal to 12 centimeter. Find the length PQ, right? Here a tangent PQ, that means a tangent PQ, we want to find the length PQ. So what we want to find? We want to find the length of the tangent alone we want to find, right? We want to find the length of the tangent, right? The tangent PQ, right? So here P is the external point or Q is the external point. See, while we are reading, the time still you have to come to the conclusion whether P is the external point or Q is the external point. See, a tangent PQ at a point P of a circle, right? So the P is nothing but point of a contact for the circle and the tangent, right? A tangent PQ at a point P of a circle. That means, so here P is nothing but point of a contact. P is nothing but point of a contact, right? P of a circle of radius 5 centimeters. So P is a point of a contact for the, what is that? Tangent and the circle, right? Tangent and the circle, line and the circle. So Q is nothing but external point. Q is nothing but external point, right? So what is it? Radius 5 centimeter. That means OP is equal to 5 centimeter, right? OP is equal to 5 centimeter. 5 centimeter meets a line through the center O. From the center O, it's meeting the point, meets the point P, and the radius is nothing but 5 centimeter, right? Meets a line through the center O at a point Q. So just we are joining the point O and Q, right? Q is a external point, just joining O and Q, so that OQ is equal to 12 centimeter. So the distance between the center point, right? Center point and the external point, right? The distance between the center point and the external point, that is OQ is equal to 12 centimeter, right? 12 centimeter. Find the length PQ. Here PQ is nothing but tangent, right? PQ is nothing but tangent and P is nothing but, see, by reading the question I am just giving the names, right? I'm not at all taking by my own, right? I'm just taking by the question, right? From the question only I'm just taking all those things, right? A tangent PQ they have said. So whether P is a external point or Q is an external point, we don't know that, but from the question itself we have short out that the P is nothing but point of contact for the line and the circle, right? P is a point of contact for the line, that is tangent and the circle, right? So Q is nothing but external point. Now they said that OP is nothing but radius, OQ is nothing but 12 centimeter, right? OQ 5 OP 5 centimeter, OQ is equal to 12 centimeter. So right angle triangle, we know that, right? Radius is always perpendicular to the tangent, right? Here tangent is nothing but PQ and OP is nothing but radius. So angle OPQ is nothing but right angle. So if it is a right angle, opposite to the right angle side, that side is nothing but hypotenuse. OQ is nothing but hypotenuse, right? So write the given, and what is it? What is the given? OP is equal to 5 centimeter, right? OP is equal to 5 centimeter. OQ is equal to 12 centimeter, right? And to find what we want to find, length of the tangent, that is PQ or QP. PQ we want to find, length of the tangent only we want to find, right? We want to find PQ equal to, already we know that, right? So in triangle OPQ, right? In right triangle OPQ, right? In right triangle OPQ, right? OQ square is equal to, right? OQ square is equal to OP square plus PQ square. OP square plus PQ square by Pythagoras theorem, right? In right triangle OPQ, OQ, what is OQ? Hypotenuse, right? Hypotenuse square is equal to adjacent square plus opposite square or base square plus altitude square, right? By Pythagoras theorem, right? By Pythagoras theorem. So already we know the value of OQ. OQ is in the 12, right? 12 centimeter. So substitute. So 12 square is equal to OP. OP is equal to 5 square plus PQ is nothing but how much? PQ is equal to, we don't know that, we just keep as it is, PQ square. 12 square is equal to 144 and 5 square is nothing but 25 plus PQ square. Just bringing this 25 to the LHS. So 144 minus 25, right? 144 minus 25. 144 minus plus 25 will become minus 25. It is equal to PQ square, right? PQ square. Just subtract how much? 119 is equal to PQ square, right? But what we are needed? We need only the length of PQ alone, right? So taking square root on both sides. So square root of PQ square is equal to square root of 119. Square root will get cancelled. So PQ is equal to, right? PQ is equal to square root of 119 centimeter. See, this is not a perfect square number. So therefore the length of the tangent, right? The length of the tangent PQ is equal to, right? Square root of 119 centimeter, right? So number 3, length of the tangent from a point A. The length of the tangent from a point A at a distance 70 centimeter. See, 70 centimeter from the center of a circle is 56 centimeter. See, we are having two measurements. One is centimeter 70 centimeter, another one is centimeter 56 centimeter. So which will be tangent and which will be the distance between the center point and the external point? Distance between the center point and the external point. So 56 or 70 centimeter. See, when they started, the length of the tangent from a point, the length of the tangent they have started. In between they are saying that the distance between the point A to the center of a circle is nothing but 70 centimeter. The length of the tangent from a point A, that means that external point, from a point A at a distance 70 centimeter from the center of a circle. So see, O is nothing but center of the circle, A is nothing but external point. The distance between center point and the external point is nothing but 70 centimeter, right? 70 centimeter, right? Is 56 centimeter. What is 56 centimeter? The length of the tangent. Here the length of the tangent is nothing but A. I'm just giving the name P. The AP is equal to 56 centimeter, right? 56 centimeter, right? Find the circumference of a circle. So we want to find the circumference of a circle. So we don't know the OP. So how we are going to find the OP? So we know that, right? OP is nothing but radius and AP is nothing but tangent. OP is perpendicular to tangent AP, right? OP is perpendicular to tangent AP, right angle triangle. So OAP is nothing but right angle triangle. OAP is a right angle triangle. By using the Pythagoras theorem, I'm just going to find the radius, right? So what we want to find? Find the circumference of the circle, right? Circumference. See, what is the formula for finding the circumference of a circle? Circumference of circle is nothing but 2 pi r, right? So if you know the radius, right, r, then we can substitute in the formula and we can find the circumference of the circle, right? So write the given. What are the given we are having? What is it? AP is equal to 56 centimeter, right? AP is equal to 56 centimeter and OA is nothing but 70 centimeter. OA is equal to 70 centimeter and OP I am just taking as r, right? R centimeter, radius, right? R centimeter. To find what we want to find? To find circumference of the circle, right? Circumference of a circle. Circumference of a circle. Okay. So we are having a right angle triangle. In right triangle, right? In right triangle OPA, right? In right triangle OPA, right? Which is the hypotenuse side. So hypotenuse side is nothing but what is it? OA, right? And this is right angle, right? And this is right angle. Opposite to the right angle is nothing but hypotenuse. So OA square is equal, right? OA square is equal to OP square plus PA square, right? OP square plus PA square, right? So we can draw the diagram in any position, right? The external point means outside the circle, wherever we are needed, we can draw the point, right? So suppose we are needed the point A here, you can draw here. Suppose in the top, no problem, you can draw in the top, right? Everything will be the same only, right? Okay, in right triangle OPA, OA square is equal to OP square plus PA square by Pythagoras theorem, right? By Pythagoras theorem. So what is the value of OA here? OA is nothing but 70 centimeter. So 70 square is equal to OP. What is OP? R, right? R square plus PA square. PA is nothing but 76, right? AP or PA. 56, right? 56 square. So what is 70 square? 7 into 7, 49. 14. 4900 is equal to R square plus 56 square. 3136. Just taking this 3136 to the LHS, then plus 3136 will become minus. So R square is equal to 4900 minus 3136. While we are subtracting, here R square is equal to 1764. But what we are needed? R alone needed. Just taking square root on both sides. So square root of R square is equal to square root of 1764, right? Square root will get cancelled. So how we will find the value of square root of 1764? By taking the SL method, right? Prime factorization 1764. So 2 table 8 times 8 times 2 times. Then 2 table, right? 4 times 4 times 1 time. 2 table not possible. 3 table 1 time 14. 4 times 2 balance 7 time, right? Still 3 table how many times? 4 times 3 4s are 12. 2 balance 27 9 times. Then 7 table 7 sevens are 7 1 times, right? So R is equal to square root of, right, 2 into 2 into 3 into 3 into 7 into 7, right? So for this pair will get come outside. First 3 into 3 1 times, 7 into 7 only 1 times. So 2 3s are 6, 6 sevens are 48. 48 centimeter. So radius is equal to 48 centimeter. Now we got the radius of a circle. But what we want to find? We want to find the circumference of circle. So therefore, circumference of a circle is equal, right? What is the formula? Circumference of a circle is equal to, right, 2 pi r, right? 2 pi r. So 2 into, see, radius is nothing but in terms of 7 multiple. So I am just taking the pi value in terms of 22 by 7. 22 by 7 into 48 centimeter, right? 48 centimeter. Sorry, a small mistake. 6 8s are only 48. 6 7s are, what is it? 42 centimeter. So radius is nothing but 42 centimeter. 1 times, right? Here how many times? 6 times, right? So 2 into 22 into 2, right? 2 into 22 into 6. It is equal to 222 are 44. 44 into 6 is equal to 264 centimeter, right? 264 centimeter. Therefore, the circumference of a circle is nothing but 264 centimeter, right? Next, we are going to see one theorem, right? And I will give you the homework sum. And today homework is nothing but 2 sums homework, right? Based on this model, you are having 2 sums as a homework and that one theorem. That theorem you have to write two times, right? You have to study thoroughly and you have to, without seeing, you have to write 2 times, right? Second property. What is the second property of the tangent? The length of tangents drawn from an external point to a circle are equal, right? The length of the tangents drawn from an external point. Here external point is nothing but A, right? And AP and AQ are the two tangents. So what we want to prove that from an external point, right, we are drawing the two tangent, that length of the two tangents are equal. We want to prove that, right? So I'm just drawing the circle, right, with the center O, right? I'm just marking the external point as A, and see AP and AQ are the tangent, right? Two tangents AP and AQ are drawn from a point A, right? Drawn from a point A to a circle with center O, to a circle with center O. What we want to prove that AP, length of AP is equal to AQ, right? AP equal to AQ. Construction, join OP, OQ and OA, right? Join OP, OQ and OA, right? Now see that now we are having two triangles, right? See, we know that by using the first property, right, OP is perpendicular to AP. OP is perpendicular to AP, and this is right angle, right? And OQ is perpendicular to AQ, right? OQ is perpendicular to AQ. Now we are having two right angle triangle. What is that? OPA and OQA, right? We are having two right angle triangle, right? I'm just taking these two right angle triangle. I'm going to prove that these two right angle triangles are congruent, right? If the two triangles are congruent, then by CPCT, what is it? Corresponding parts of a congruent triangles are equal, right? Corresponding parts of a congruent triangles are equal. So I'm going to prove that with the help of the congruence rule. I'm going to prove that these two triangles are congruent, right? I'm just taking these two triangle in triangle OPA, right? In triangle OPA and triangle OQA, right? In triangle OQA, I'm just taking these two triangle. See that OA is nothing but common for both the triangle, right? OA is nothing but common for both the triangle. OA is equal to OA common, right? And we know the angle OP is nothing but OPA is equal to 90 degree and OQA is also 90 degree, right? By using that property, OPA equal to 90 and OQA is 90. So OPA is equal to OQA, each 90 degree, right? And already we know that OP is equal to OQ. How? OP and OQ are radius of a circle, right? OP and OQ are the length of OP is equal to OQ, because OP and OQ are radius. So OP is equal to OQ. See, so what congruence rule will be applicable? See, right angle, both right angles are equal, both the hypotenuse, right? OA is equal and one side is equal for the two triangles. So right, RHS property. By RHS congruence rule, right? By RHS, we can say that the two triangles are congruent. The triangle OPA and triangle OQA are both will be congruent. Both will be congruent, right? Triangle OBA is congruent to triangle OQA, right? By which property? RHS congruence rule. RHS, right? Right angle, hypotenuse, side, right? If these two triangles are congruent, then by CPCT, right? Corresponding parts of a congruent triangle. By CPCT, I am just saying that AP is equal to AQ. Hence, AP is equal to AQ. Hence, it is. Right, and we are having one more method, right? We are having one more method to prove that what is that AP is equal to AQ. Actually, this is theorem method, right? But generally, by using right angle triangle property, right? Right angle triangle, by using the Pythagoras theorem property, I am just going to prove that AP is equal to AQ. I am just taking this first right angle triangle, right? We know that by Pythagoras theorem, what is it? I'm just taking that OPA triangle, right? OPA triangle, OA square is equal to what is it? OP square plus PA square, right? OP square plus. So this is not needed, only for your understanding purpose alone. I'm just explaining, right? You don't want to write in your note, just to keep it in your mind alone, right? I'm just taking the first right angle triangle OPA. What is it? OA square is equal, right? OA square is equal to OP square, right? OP square plus PA square, right? PA square, right? I'm just bringing this OP square to the LHS. Then OA square minus OP square is equal to PA square, right? Is equal to PA square. Already we know that OP is equal to OQ, because OP and OQ are the radius. So instead of OP, shall I substitute OQ, right? Instead of OP, shall I substitute OQ? So OA square minus OQ square is equal to PA square, right? PA square, right? So this is the in right triangle OAP, right? In right triangle OAP, I have used the Pythagoras theorem. Next, I am just taking this in right triangle OQA. In right triangle OQA, right? Then OA square is equal, right? OA square is equal to what is it? AQ square plus OQ square, right? AQ square plus OQ square. Bringing this OQ square to the LHS, right? OQ square to the LHS, then it will become what is it? AQ square is equal to OA square minus OQ square, right? OQ square. Just compare this is the image from the right angle triangle. First right angle triangle I have find it, and from the second right angle triangle I have find it, right? So just compare 1 and 2. OA square minus OQ square, OA square minus OQ square. LHS are equal. If LHS are equal, then from 1 and 2, PA square is equal to AQ square. PA square is equal to A square. Taking square root on both sides, then it will become PA is equal to QA or AQ, whatever it may be. Hence it is. Understood? So I am just see only that we have what property. I am just taking this triangle, and by using the Pythagoras theorem, I am just proving that. And instead of this OP alone, I am just substituting OQ, because OP is equal to OQ. right? But it is not needed, only for your understanding purpose, right? If you want to, if you are needed, you can just note down in pencil, right? But this is the proof, right? By using the congruence rule alone, we have to prove that the the two tangents are equal, right? Today homework sum, right? And today homework is nothing but sum number 4 and sum number 5, two sums, right? Based on that model sums, and one more theorem, right? You have to throw the theorem and write 2 times, right? Okay, sum number 4, find the diameter of a circle, right? Find the diameter of a circle. How we want to find the diameter of circle? If we know the radius of the circle, then by multiplying by 2, we'll get the diameter of a circle. So first we want to find the radius. So how we are going to find the radius? See that if the length of the tangent from a point A, if the length of the tangent from a point A at a distance 40 centimeter from the center of the circle is 32 centimeter, right? So they have given the length of the tangent and distance between the center point to the external point, right? Center point to the external point. From here, external point is nothing but A, right? External point is nothing but A. From the point A to the center point O, what is the distance? 40 or 32? 40 centimeter, right? Same thing. The length of, see, they have started with the length of the tangent. In between, they are saying that the distance between the center to the point A is nothing but 40 centimeter. And then only they are saying that the length of tangent is nothing but 32 centimeter. So we have to differentiate. That's very important, right? So we know that what is it? Among the right angle triangle, we know among the 3 sides, they have given 2 sides. With the help of Pythagoras theorem, we are going to find the third side, right? The final answer is nothing but 48 centimeter. What is final answer? Diameter of the circle is nothing but 48 centimeter, right? Sum number 5, the length of the tangent from a point X. The length of the tangent from a point X. That X is nothing but what is it? The X is nothing but on the circle, or what is it? At a distance 35 centimeter. So the X is nothing but external point, right? The point X is nothing but external point to the circle, right? The length of the tangent from a point X at a distance 35 centimeter from the center of the circle is 28 centimeter. So the 35 centimeter is nothing but distance between the center point to the external point, and tangent is, length of the tangent is nothing but 28 centimeter. Find the area of the circle. So what is the formula of finding the area of circle? Pi r square. For that, what we are needed? Radius is needed. So with the help of these two values, we are going to find the radius of the circle, right? By using that property, Pythagoras theorem property, right? And the final answer is nothing but 1386 centimeter square. That is, the area of the circle is nothing but 1386 centimeter square, right? Thank you. And tomorrow we will see still we are having 2 more theorems, right? I think so. We have completed 2 theorems, still 2 more theorems, and some properties we are having, right? Some properties while we are solving, right? After solving that, I will tell you that this is the property. While we are coming like this, we have to use this property like this. I am just explaining, right? One by one we will learn it, right? While we are solving by understanding, right? After you are understanding that the property, then you can thorough it, right? Thank you.